Howdy everyone. Today we are talking about lesson 8.5, angles of elevation and depression. Let me be very clear, we're not talking about depression as in mental health. We're talking about angles of elevation and angles of depression. The angles are not sad, it has to do with the direction that you're looking. So just so we're all on the same page there. So let's start with defining these. If we have a person that is looking at two different objects. There's really three options. You can have an object above you, you can have an object slightly below you, or you could also have an object like where this red box is, which is directly in front of you, right? Now, when we're describing those locations, we use a horizontal line as our reference. So if I'm looking from this point here, right? I'm looking from this point here. A horizontal line going straight across here is my reference point. Okay? If I'm looking above that horizontal line, right? If I'm looking above the horizontal line at an object like so, then that's called an angle of elevation. And that angle is specifically the angle between the line that I'm looking and the horizontal line. Okay? So the key thing here is to always remember, where is the horizontal line? Okay, that's a huge landmark, and a lot of mistakes are made on this when students go from the ground or from a slanted object. Okay, you're always looking from the horizontal. Okay, similarly, if I'm looking at an object below me, so let's say I'm looking at now, this object down here, I'll change the color to make it distinct from the horizontal. Say I'm looking at this object here. If I'm looking at that and I want to describe how I'm looking at it, we're again talking about it from the horizontal line. So this horizontal line that we initially drew is still our reference point. Okay? And from that point, we can have a line of sight here that forms an angle. So between the horizontal and the line of sight that we have, that forms an angle of depression. Okay, so it's the angle from the horizontal to the object that you're viewing. So it's from the horizontal to the object. Okay, so if it helps to write that down, to the object. Okay, horizontal line to the object. All right. So if the red box that I drew in here, if we're dealing with this box here, the angle, it would not have an angle of depression and it would not have an angle of elevation because it's on the horizontal line, or you could call it a 0 degree angle of elevation or a 0 degree angle of depression, depending on if you're an optimist or a pessimist. It's up to you. If you didn't get that joke, rewind it and think about it. Okay, let's look at an example. Here we go. So let's say we have a ship and a jet. Okay, and we're gonna be passive here and say the jet is trying to land on the ship, not that it's trying to shoot the ship. Okay, so let's say the jet needs to land on the ship like it's an aircraft carrier, right? Now some information is provided for us. We know that the jet is 10,000 feet above the surface. Okay, and we also know that the angle of elevation is 20 degrees. Okay, now before we look into solving this problem, I want to point something out here, because if you notice at the top of the screen here, it also gives us the angle of depression, right? It also gives us the angle of depression. Now, if I wanted to compare those, if you notice, this orange line that I drew at the bottom, is exactly horizontal, right? Well, this orange line that I'm going to trace at the top here is also, that's supposed to be on the black dotted line, is also horizontal, which means these two lines are what? Parallel, right? So if I know those two lines are parallel, then what can I say about these two angles here? Well, we have a transversal, right? We have two parallel lines cut by a transversal, which means that the alternate interior angles, which again, if you're ever confused as to how to remember the alternate interior angles, you have if it forms a z, right, the angles inside the z, those must be congruent, right? Those must be congruent. So we have the angle of depression from the jet to the ship. So the angle of depression from the jet to the ship is congruent to the, so it's the angle of depression, is congruent to the angle of elevation, right? Elevation from the ship to the jet, right? So hopefully you can see that. That seems, pretty straightforward. It should be somewhat of a review from early on in the year. But if not, just, nice quick review for you. So let's look at how to solve this problem. So if we have, let me erase some of this stuff here, just so it becomes more clear again. So let's again look at our given information. Okay, so we have the height is 10,000 feet, the angle of elevation is 20 degrees, and we're looking to solve for x and for y. So to do this, we're going to set up a trig function. Again, you have options when you're doing a trig function. You can do sine, you can do cosine, and you can do tangent. So hopefully you remember so, ka, toa. Right, where sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So right away, I hope you realize we can eliminate using cosine in this case to solve for x or y, because that would give us cosine of x, not of x because I already used x, cosine of 20, right, because that's the angle measure. Cosine of 20 equals the adjacent leg, which is y, over the hypotenuse, which is x, right? So that gives us two variables, which means you cannot solve for the actual equation, which means we're not going to use cosine. And in case any of you are skeptics, this is a right angle, right? We're assuming it's straight up. Okay, so we can use sine to solve for x. We can use tangent to solve for y. So we're going to do both. So first of all, if we have set up my first equation, we can say that sine of, again, my angle of elevation is 20 degrees, equals the opposite over the hypotenuse. So the opposite is the leg that is on the other side of the triangle, which is the 10,000, right? So the opposite, which is 10,000, over the hypotenuse, which is x, okay? Now to solve for this, you need to, basically we're going to multiply both sides by x, and you get x sine 20 equals 10,000. And then divide both sides by sine of 20, so you get x equals 10,000 over sine of 20. Now if you want, just to, if you notice a pattern, that the x and the sine 20 just basically switch places, right? So we started with sine 20 equals 10,000 over x, we finished with x equals 10,000 over sine 20. And that would be your exact answer, okay? So if it's not looking for a an actual, if it's not looking for rounding to the nearest hundredth or whatever it is, that would be your exact answer, okay? Hopefully you realize that it should be more than 10,000 feet, because the 10,000 is opposite 20 degrees, which is a smaller angle than this other angle here, which is 70 degrees, right? Put double so they're not congruent. Anyway, if you want to plug it into your calculator, go ahead, but I'm more concerned about exact answers. So how do we then, you might hear my dog in the background walking around. That's neither here nor there. So we have, now let's solve for y. Okay, we want to solve for y. To solve for y, we can use cosine if we want, because we know x, but x is kind of in this form here, which is difficult to plug in, right? So I'm going to use tangent, and I'm going to say that tangent, we're going to create a little wall here so we don't get it all mixed up. Tangent of 20 equals what? Tangent is opposite over adjacent. What's the opposite? The opposite is 10,000. 1, 2, 3 over the adjacent leg, which is y. So if I want to solve for this, again, as you noticed before, the y and the tan 20 should just switch places, and you get y equals 10,000 over tan 20. And again, if you want to plug that into your calculator, you may. I just realized I made a mistake before. If I said x should be less than 10,000, but x is the hypotenuse, right? So x has to be more than 10,000 because it needs to be longer than the side length. I was looking at y when I said that. Y should be more than 10,000. X should be a lot more than 10,000 as well. I may have just confused you. Apologies if I did, but hopefully you at least understand how to do the problem. If you want to plug them into your calculator, feel free. Okay, feel free. All right, let's see if we can move on to example 2 here. This one it's similar to the other one. There's just a slight difference. Okay, and we talked about this a little bit before. We have a ship and we have an anchor, and we know that the cord, or the chain, not a cord, the chain connecting these things is 200 meters long. Okay, and this here, hopefully you can realize that this angle here is the angle of depression, right? So from the horizontal going downwards, down in depression, both start with D, right? Going down, we have 50 degrees there, so my angle of depression is 50 degrees. Now if I'm trying to solve for x, I need to know information about the actual triangle, right? So there's a couple ways of looking at it. You can either say, oh well, these two angles here that I've highlighted in green are alternate interior angles, meaning they both must be 50 degrees, which is valid. Or you could say that these two angles here form a, that was terrible, form a right angle, right? And if one of them is 50, then the other must be 40, right? Either option works. But now, once you have one of those angles, whether the 50 or the 40, you can then solve for x using a trig function. So I'm going to do it both ways real quick, just kind of set it up for you. So let's start with the 50 degree angle. If I'm dealing with the 50 degree angle, x is opposite that 50 degree angle, right? So if I'm dealing with opposite and hypotenuse, hopefully you realize we should be using sine. So sine of what? Sine of 50 degrees would give me x over 200, or the opposite over the hypotenuse, right? And if I solve for x, I just get x equals 200 sine of 50 degrees. Okay, you can type that in your calculator, or you could Google that if you want. You can just type in 200 sin 50, and Google would pop the answer up for you as well. If you did not notice that alternate interior angles and you use the 40, I'll show you how to do that as well, because I'm a nice person. But in that case, we would no longer be dealing with an opposite side length. We'd be dealing with the adjacent leg length, which means we'd be dealing with cosine of 40 now, right? Cosine of 40 would be x over 200. Therefore, x equals, multiply both sides by 200. You get 200 cosine 40. And if you type both those in your calculator, you will get the same thing. So we're going to look at kind of a tougher problem in the next slide. But this is the basics of angle of elevation and depression. So if you want to look at a problem that they can throw a curveball at you, not a literal curveball, but then watch part 2. All right, but hope you learned something new, and see you in the next video.